Royce's
And
best
don't
job
deny that.
offer from Young Harris is McDonald's.
See, he's digging this hole.
I do actually know West Point graduate is unemployed, but.
Oh! Yeah.
I know one too.
All right, here we go.
My grandpa always had employees.
So,
He was baby.
let's take a look at this problem, because it looks very, very complicated. But I am hopeful that we can figure it out. Now, all that is given, okay? That is part of the problem, that's just given. Now, the question is, I can't remember if I turned it on. The question is,
What? I know.
find the sine of alpha plus beta. Now, I'm using the Greek letters alpha and beta. If you want to make that A and B, or X and Y, or whatever, it doesn't matter. I need variables, okay? Now, we're going to do two things before we get started. Are you listening here? Two things. The first thing we're going to do is write out the formula that we're going to use. So this is the sine of, on your sheet, it's u plus v. So what does that say? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. All right, everybody find that on your sheet?
Is that symbol just an X?
That is an alpha, and that is a beta. I just got done telling you, you can make them X and Y, A and B, U and V, if you want to match your sheet,
Greek letters.
Is that a fish?
okay? Now, second thing, so the first thing we do is write out the formula we're gonna use. The second thing we do is draw a picture of both angles, okay? So I am going to draw a picture of angle alpha, A, U, whatever, and I'm going to draw a picture of angle beta. This tells me where to draw it. So what does pi over 2 to pi mean? Think about going around.
90 to 180.
It's 90 to 180, so it would be here in quadrant 2. Does everybody agree with that?
Oh, I do agree with that.
And I know that the sine that is opposite over hypotenuse is 3/5.
Yep.
So then I'll do my Pythagorean theorem to find that side. And that is a Pythagorean triple, so it's actually going to be -4. Because 3 squared plus 4 squared is 5 squared. And it's negative because of the location. All right, now I'm going to do the same thing with beta. What does this tell me? Where's beta?
Is going to be.
That's 360.
270.
That's
Right, it's in
270.
quadrant 4.
So won't that be right here in quadrant 4? And the cosine that is adjacent over hypotenuse is 5/13.
Yep.
And I'll do my Pythagorean theorem to find that one. So 5 squared plus what squared gives me 13 squared. Don't just stare at me. I'm
What
not
was his name?
checking.
I don't know.
Pi squared plus what?
What is it?
I'm just gonna wait for something else.
Pi squared plus what?
140.
13, bro.
12.
12. And actually, this one is also negative because of where we are.
The human calculator.
Now, it is definitely possible, this was our first example, so the numbers are really nice. Please understand that, you see, it would be possible to be getting radicals here, right? Yeah, I just rigged it so it came out nice for us, our first one. Okay, so first thing we do, write out the formula we need for the problem. Second thing we do, draw a picture of the given. Now it's easy. Now we just take the numbers from the triangles and put them into our formula. So sine alpha, that's alpha up there on the top. What's the sine of alpha? 3/5. Opposite over hypotenuse. What's the cosine of beta? Cosine of beta. 5/13. What's the cosine of alpha?
-4/5.
-4/5. And the sine of beta?
-12/13.
-12/13. Now, I know you can simplify this, but don't, because ultimately we're gonna be adding these, and it's gonna be good to have a common denominator. So this is gonna be 15/65 plus 48/65. And that's gonna add up to 63/65. And there you go. Done.
I know.
I love fractions.
Now, the good news is, all of these problems involve the same given. So I'm gonna leave all this up here, we're gonna use all of that again, we just have a different problem now. So problem 2 says, we're gonna find the tangent of alpha minus beta. So what formula am I going to use? Find the formula on your sheet. What does it say? Tangent tangent of the first minus tangent of the second over 1 plus tangent. You have to be able to use your formulas when the letters are different. It's the pattern you're looking at. Tan plus or tan minus tan over 1 plus tan. Okay, so now I'm gonna look at my picture. What is the tangent of alpha? -3/4. What is the tangent of beta? -12/5. And that's over 1 plus those two numbers times each other. Alright, so what have we got? On top we have -3/4 plus 12/5, double negative there. And on the bottom we have 1 plus 36/20. Okay, now, we've run into this situation before where we have a big fraction that's made up of smaller fractions. Anybody remember how we handled that before? Multiply by the common denominator. So I am gonna multiply everything by 20. Now that includes the 1, everything by 20. Now the bottom will be 20 plus 36. Does everybody see that? Now the top, you gotta be careful. You multiply by 20, so the 4 will cancel, but leave a 5. So that's -15. And what about here? 5 will go into that 20, 4 times 48. The idea, by multiplying by 20, you got rid of all the denominators. That's why you did that. So now we end up with, what? 33 over 56. And that's your answer. Okay,
What's up, Charlie?
all right. Problem C. Cosine 2 alpha. All right, find your formula. This one, you have a choice. It makes no difference which one you need at all. I mean, which one you want to use, cosine 2 alpha.
You can just choose the one you want.
Choose which one you want. There's 3 versions there, pick the one you want. He wants to do 2 cosine squared minus 1, that's fine. That's fine. Any of them will work, you'll get the same answer, and it's basically the same amount of work. Okay? So, what's the cosine of alpha? Look at your picture. What is the cosine of alpha?
Negative 4.
-4/5. But you have to square that. So it's going to be 16/25. Right? And that's 32/25 minus 1. What do I do with that?
Common amount.
Get a common denominator. So it's 32/25 minus 25/25. So I got 7/25. What about you?
Same.
And you would have gotten the same answer if you would have used 1 minus 2 sine squared or cosine squared minus sine squared, just whatever you want. All right, last one, cosine beta over 2. Cosine beta over 2.
I'm gonna reset it for you.
Square root,
Plus or minus square root.
1 plus
The key
cosine
change.
over 2.
Perfect, that's the one we want. You don't have an option on that one. You do have an option on the tangent half angle, but not the cosine. That is it right there. That's your formula. Okay, so here we go. We got plus or minus. One plus the cosine of beta. What is the cosine of beta?
5/13.
5/13. Now, that whole thing is under the radical, so be careful when you draw it to keep the whole fraction underneath. Is that all right? What are you gonna do with that? Look at that right there. What might I do with that? Multiply by 13, right? So I'm gonna multiply everything by 13, and that's everything. So I'm gonna have plus or minus the square root of 13 plus 5 over 26. So I have the square root of 18 over 26, which that actually reduces. So it would be the square root of 9/13.
Sure would.
Would you agree that that would be 3 over root 13?
Yeah.
Break it down 2 3s.
And then we could say 3 root 13 over 13 if we wanted it to look really nice, rationalize it. Now, there's one more thing we have to decide.
Plus or minus.
Is it positive or is it negative?
Positive.
Now, this is very easy, but you also have to pay attention. Remember, we are finding the cosine of half the angle. We know that the whole angle is between 270 and 360. Would you agree with that? 270, 360. That's where the whole angle is. So if I cut that in half, that's because that's my problem, is half. Where is that? Half of beta is between 135 and 180.
That's negative.
Which means it's in quadrant 2, and the cosine in quadrant 2 is negative. That is tricky. Easy, but you really have to lock in.
So it's negative.
Negative 3 root 13 over 13, yeah. Okay. Now, I was gonna step aside from that for a moment, and that takes care of the notes, so that homework is due on Monday. 5-4 homework due on Monday. I want you to get out the review packet that I gave you that one day, big packet, that's several pages. We did a few from the front when
How
we
many do
were
you have left?
practicing. But I want you to turn in that review packet.
Are we doing any of 5-5? Is it?
No, we're having a test after 5-1, 5-4.
So we're not doing that.
No, we're not doing anything 5-5 till after our test.
We gotta do it and then they're gonna do free practice.
Yes, yes. The front page says verify the following. We're going to page, wait, not page 4. We're going to page 6. We're going to page 6. For e-learning, you will need this packet, because I will be working on pages from this packet. All right, so make sure you have this with you. All right, here we go. Page 6. It's just an old quiz I gave a long time ago, and I thought we could do it, kind of a review of some basic stuff. So here we go. Look at number 1.
What is this thing?
This is formula identification. What formula is cosine cosine minus sine sine?
Cosine U plus B.
Cosine u plus b. So this would be the cosine of 10 plus 4?
Cosine 14.
Cosine 14. That's what you write down. That's the answer. Cosine 14. Alright, let's look at number 2. Square root of 1 minus cosine 50 over 2. 1 square root 1 minus cosine over 2 is a formula for what? Sine half of something, and the something is 50. So this is a formula for the sine of 25. Cosine squared minus sine squared. What is that? Now be careful. If that were a plus, the answer would be 1. But it's a minus, so it's something else. What is that the formula for?
Cosine 184.
What, the cosine of twice the angle? And the angle is 92, so it's the cosine of 184. Can you do number 4?
Of course I can.
Tan 18. Did everybody get tan 18?
You gotta.
Tan u plus v?
Yeah.
What about the last one, number 5?
That's tricky.
Sine 62.
It's the formula for the
Sine
sine
2x.
of
72.
2 theta.
2x.
So 2 times 36, that's a formula for the sine of 72.
Beta.
Is there a sigma chi problem?
You gotta work on your business.
Everybody with us?
Yep.
All right, now, find the exact
Solve for
value
sigma chi.
of the sine of 75. Who can remember
It's like,
how we do that?
it's like not enough air in it.
What?
Half angle?
We could do it as a half
Hey, hold
angle,
on.
we could also do it as a 75.
Oh,
45 plus 30.
Are we in the bonus?
Yep.
So I'm gonna do it that way, Harper, if it's okay, because it's easier and it doesn't matter. So you want the exact value, oh, sine
You're okay.
75. So 45 plus 30. So that's u plus v. So that formula says sine first, so think of that for u and your v. So sine 45 cosine 30 plus cosine 45 sine 30.
Yeah.
Now, maybe you have these numbers memorized and maybe you don't, it's okay. I'm gonna draw a 45-degree angle and I'm gonna draw a 30-degree angle. Those are my two pictures for this problem. Right?
Yep.
And I know 45 is 1 root 2, and I know 30 is 1 2 root 3, like that. And I'm gonna do just what I was practicing earlier. I'm gonna take numbers from my picture and plug them into the formula. So, sine 45, 1 over root 2, so we're gonna say root 2 over 2. 1 over root 2 is root 2 over 2, okay?
Yep.
And the sine and the cosine are the same for 45, so they're both root 2 over 2. Now cosine 30 is root 3 over 2, and sine 30 is 1/2. So now we'll multiply each set, so that's gonna be root 6 over 4, root 2 over 4, and then remember, since they have the same denominator, we can't combine them, but we'll write them as one fraction. But they don't add together. Remember doing that?
Yep.
Okay, perfect. All right, let's look now. There's one more I wanted to look at. Let's look at page 3. Page 3. This was a quiz I gave at some point. Let's see how we do. Take a second, you and your partner, and see if you can get number 1. See if you can recognize what formulas you've got there. Remember, the kids that took this quiz did it with no reference sheet.
It's sine 5.
Don't talk, just do them all. We're doing all 3 of them. I said number 1, which has an A, B, and a C. A, B, and C.
Man, I'm close. Do you yell, Brandon?
Eli, shh.
Thank you.
You guys hungry? I'm told to help people with that. No, you gotta get rid of half of that stuff.
Oh, I get it.
Yes, it is.
We're gonna embrace this stuff.
Like me, tell me confused.
Which one that he has? Do you like see a formula that says minus sine?
It wasn't.
Huh? You see that? It's the third one down.
Well,
And
you
then
hit
U
on
plus
one
V, so
side,
it's 86,
adjustable one.
53 plus
But you
33
can
is
run it
86.
if you want.
Wish we did one.
All right, we're gonna check number one, okay? What do we have? Erica, you had your hand up. What do we have for A? Sine 5, right? It's sine U minus V, and U and V are 18 and 13, so it's sine 5. All right, B, who got a B? Tan 7, because it's the tangent of U minus V. Tan minus tan over 1 plus tan tan. All right, and how about C?
What
It's
is this?
cosine 86. You have to write a function down, don't just say 86, you gotta have a function there. It's the cosine, because it's cosine cosine minus sine sine, which is the formula for the cosine of U plus V. And U and V are 53 and 33. All right, how are we there? We good on that? Perfect. All right, you have a thought on cosine 195?
Cosine 150 plus 45.
I heard a
like it.
150 plus 45. Now, I know I said this before, but I want you to be comfortable with the fact you don't have to use 150 and 45. There are other things that you could use. Remember that day we made all our special angles? You know, we have all the 30s, all the 60s, and all the 45s. So any combination of those that gives you 195 will work. Personally, when my angle ends in 5, I always use 45. It's just easier for me that way, but you don't have to. All right, got it. What's the formula say for the cosine of 150 plus 45?
Cosine 150, cosine 45 minus sine 150, sine 45.
Isn't that the formula you just did in problem 1C? Cosine, cosine minus sine, sine, and that's the sum for the cosine U plus V. Okay. Now, I just erased my 45-degree angle. Does anybody remember what the sine and cosine of 45 are? Root 2 over 2. They're both root 2 over 2. So I'm not gonna draw 45, but I'm going to have to draw 150. 150 is over here. Would everybody agree with that?
Yeah.
And the reference angle, oh, 30, that's a 30. Right? 150 is 30 less than 180. So 150 should be in your 30 list. All right, so 1, 2, negative root 3, right there is gonna catch you. I've noticed that in some of your homework. All right, here we go. What's the cosine of 150? Negative root 3 over 2. And the sine of 150? 1/2. So we have negative root 6 minus root 2 all over 4. I kind of skipped that intermediate step. Is that okay with you?
Yeah.
Put them together, they're both over 4. Got it. Okay? Now you're proving this one. So in other words, you want to do something over here and hopefully end up with that. So this is the sine of an angle plus an angle. This is your U and your V, right? Your U and your V. So what's this going to be when I expand it now? Sine 90 cosine x, this is your U and your V, plus cosine 90 sine x.
Yep.
Now 90 is right here, right? 90 right here. cosine of 90 is 0. And the sine of 90 is 1. I know, it stinks. They have power somewhere. They have control of it. He can pull up his computer and know exactly what the temperature in the room is. Just turn it off. Ugh. Anyway, here we go. Did it work? I plugged in sine 90 was 1 and cosine 90 was 0. Doesn't this go away? 0 times something is 0. And what happens here? 1 times cosine is just cosine, and that's what we want. It's got a backside. A backside. Okay, this is another proof. So you are going to do something over here and hopefully end up with sine. Anybody know what cosecant is?
1 over sine.
1 over sine, perfect, beautiful. Cosine is just cosine. What's cotangent? I heard two things. I
Cosine over
heard
sine.
1 over tangent, which is true, but probably not helpful. So cosine over sine would be more helpful. Because I want to end up with a sine. So I like to get sines going in the problem. So I have 1 over sine minus cosine squared over sine. And they have a common denominator, so I'll write it as 1 fraction. Wait a minute. What is 1 minus cosine squared?
Sine squared.
Remember, anything we talk about, if it isn't already on your sheet, you can add it to your sheet. And that's gonna cancel and give us sine, which is what we wanted. And then the last one is one of the problems like we did in our notes at the very beginning of class. So let's practice this last thing. It was a bonus back in the day, but it's on your homework, so let's go ahead and do this. So here's the given. We know the tangent is 4/3, and where is this angle? Draw a picture of it. Which quadrant 3? And the opposite and the adjacent, watch those negatives, right? They cancel, but they're there, they're in the picture. And then, okay, so the hypotenuse is 5. Pythagorean theorem, 3 squared plus 4 squared. And then the secant is negative 13/5. And that one is in quadrant 2. Alright, so this is x. Y. So y is in quadrant 2. And the secant, which is the reciprocal of the cosine, is, so cosine is negative 5/13. Okay? So I need to do the Pythagorean theorem. And 13 squared minus minus 5 squared is 144, so that's 12. Positive 12. Alright, so all you've done so far is draw a picture of the given. Now we're going to write the formula. Now notice I asked them for the cosecant. We don't have that. But I do know that the cosecant is the reciprocal of the sine. So think about those problems we did earlier. When I did a cosine problem, if I wanted the secant, couldn't I just flip that over? So I'm going to go ahead and find the sine, and then I'll remember to flip it when I get to the end. Okay, so here we go. What is the formula for the sine of x minus y? Sine x cosine y minus cosine x sine y. So I'm not flipping now. I'm going to go ahead and get my answer, and then I'll flip that. Don't flip here. Do not be flipping anything in here. We have to get our answer, and we'll flip it. All right, here we go. Look at your pictures. What is the sine of x? Negative 4 over 5. What is the cosine of y? Negative 5/13. Right? Opposite over Jason. I mean, opposite over hypotenuse. Jason over hypotenuse. Okay. Cosine x is negative 3/5. And sine y is 12/13. So multiplying gives me 20/65 plus 36/65. So it's minus it. So it is minus, but it's negative. So did you get 56/65? That's the sine. So the cosecant will be 65/56. All right? Okay, I need you to go to the back of page 5. The back of page 5. We have not done one of these in a while. Okay, are we on the back of page 5? First problem says we are going to solve this equation. And we are going to solve, we're going to answer in radians. So if we get, we won't say 30 degrees, we'll say 5/6. All right. So tell me what you remember from this kind of thing.
First you gotta change it to 1 minus 2 sine squared.
You gotta change cosine 2x. You cannot have a 2x in the same problem with a plain x. This is the formula where you have a choice, and Blake says he chooses this version. So cosine 2x is 1 minus 2 sine squared. And given that we already have a sine in the problem, that makes really good sense, doesn't it? Okay, Charlie, you with me? You sure?
Yeah.
All right. Now what do I want to do?
Get everything else.
Get it set equal to 0. And I have a thing, an issue with my square being positive, so I'm gonna move everything over to that side. So I'm gonna add 2 sine squared over here to this side, and I'm going to subtract 1. So I have 2 sine squared minus 3 sine plus 1. So I added 2 sine squared, subtracted 1, so I have it equal to 0. Wouldn't it be magnificent if this thing factored? This is a quadratic. If it did factor, wouldn't it have to be 2 sine and 1 sine?
Yeah.
And I mean, choice has got to be 1 and 1. And they both have to be negative to make that positive. Does that work? Outside would be -2. Inside would be -1, which gives me -3. If that equation scares you, it's the same as this. Only instead of x's, you have sine x's. Okay, what do we do now? 7 equal to 0. So this one will say sine equals 1/2. Is that too much? Too many skip steps? Sine equals 1/2, or sine equals 1 is the easy one. That's on my circle. I look around the circle, and I'm looking for where y, which is sine, y is 1. There's only one place on that circle where y is 1, and it's right there, right? So in degrees, that would be 90, but in radians, it's this one's not so easy. I gotta stop and think. There's an angle that has a sine of 1/2, so opposite over hypotenuse is 1/2, and this would be √3, and that angle right there I recognize is a 30, but in radians, 30 is a 1/6 of 180, so this is pi over 6. However, this is the tricky part. There's another one, so
5/6.
where else is the sine, which is y, positive? Not quadrant 3. Quadrant 2. It's positive in quadrant 2. Kids, y would be positive here, right? In quadrant 3, y is negative. I want to be over here. So what angle is that? 5/6. So it's easy, guys. It's easy. Don't overcomplicate it. This is pi, right? This is a 6. So what's 1 minus a 6? 5/6. So your answers are 1/6 and 5/6. I don't know. People can think of all my pencils. I'm really down. I gotta start finding more. All right, let's see if we can get this page finished. I don't know if we can or not. Find the exact value of the sine of 345. Okay, you know what to do. Sine 345. What do you want to do?
315 plus 30.
Okay, that'll work. Wouldn't be what jumps out at me, but it works, right? I gotta find a combination from my list of possibilities, and that'll work. what's the formula for the sine of u plus v? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. So far, so good, you guys? Alright, so now I gotta start plugging in the numbers. Now, 315 is going to be the 45-degree angle in quadrant 4. Does that make sense to everybody? So here are the sides. So the sine will be negative root 2 over 2, but the cosine will be positive root 2 over 2. Your 45s always match, sine and cosine, except for sine, S-I-G-N. You have to find out positive or negative. So you with me? Everybody good? All right, well, 30, I've drawn it so many times, I'll draw it one more time. Remember, you can have that drawn on your paper if that's easier for you, I don't care. So what's the cosine of 30? Root 3 over 2? Right? What's the sine of 30? Half. Now put all this together, so it's something over 4. Negative root 6 plus root 2. Got it?
Yep.
All right, number 3. What a mess this is. What do you think we ought to do first?
Try and get as many sides as possible.
Try to get as many sines and cosines as possible. I love it. That's exactly right. So we've got sine over 1 times 1 over cosine. That's my numerator. A sine is a sine, so there's not much you can do with it. I put them over the 1 to help me multiply, but you can't change it. Secant, on the other hand, is 1 over cosine. All right, what's tangent? Sine over cosine. And cotangent is cosine over sine. Now, I am going to rewrite that numerator as sine over cosine. I'm not trying to pull a fast one on you. This is a multiply. So isn't that sine over cosine? And then my denominator is all this. Now, you can do this however it makes sense to you. But I like to find the common denominator of the whole shebang and multiply everything by it. So if you look at all the fractions, the common denominator would be sine times cosine. Would you agree with that? So I'm going to multiply everything by sine times cosine. The reason I did that is so that all of the denominators will cancel. So what's on top? Sine squared. What's on the bottom? What's right here? Another sine squared, right? Plus, what's over here? Oh my golly! Sine squared and cosine squared is 1. So we are left with sine squared, which is exactly what we were supposed to be ending up with. All right, quickly. Number 4. These are more of these simplified 36. Sine 2 times sine 36. How about B? Sine 43. Sine cosine minus cosine sine, sine 43. What's C? Cosine 70. Cosine cosine plus sine sine is cosine u minus v. So cosine 70. And then the last one, cosine 102. Perfect. Next time I see you in person, my friends, we're gonna have a little quiz. Quiz is gonna have a problem on it, like number 2. One we just did, cosine or sine 245. We're gonna have a problem like that to do. And you're gonna have some like number 4 to do. And you're going to have one simple verification, like on page 3, number 3. So it will be a simple one using your formulas. Alright, so everybody clear on that? Next time I see you in person. It'll be like the sine of 245. It'll be like those ones that you just did to figure out what ones are. And then it'll be one a simple verification, like number 3 on page 3. Okay, tomorrow we'll be doing review, straight review out of this packet. My goal is to have a test over this sometime next week, I'll run the 5-4. So today all we did was review, tomorrow
Hello,
we're gonna
Peter. As we had moved on here, a reminder, there's a national example of Caledonia 1150. And now let us pause to be mindful of all of God's blessings.